Tonight's event is hosted by Argo Digital. First, I'd like to introduce tonight's moderator, Jason Abruzzi. Jason is a business reporter at Mashable. Prior to working at Mashable, Jason served as markets reporter and web producer at the Financial Times. Jason holds a BS in journalism from Boston University and an MA in international affairs from Australian National University. So, welcome, Jason. Thanks, and I'll turn it over.
Great, thanks. So I wanted to start off by introducing the panelists. We're going to go start on the left. That's Andrew Boskowski. Did I get that?
Works for me.
Awesome. He's the co-founder and CEO of DataDriven. They work on quantifying things that aren't entirely quantified, figuring out how to use that in data, which we'll be talking about on this panel. Beside him is Andy Breen. He's the Senior Vice President for Argo Digital. He's also an adjunct professor at NYU Stern School of Business. Last but definitely not least, Dr. Sambit Sahu. He's a Senior Research Scientist at IBM Watson Research, also an adjunct professor, but at Columbia University. Guys, thanks for having Thank you. So we're talking about data and insurance, and you don't often hear the word data these days without big in front of it. It's big data. There seems to be no other kind of data. I guess, do you guys miss the days of small data? We'll start with Samba.
Right, can you hear me?
I actually do think you have to take the mic.
Thanks to social media, last 5 years actually we have generated more than 90% of the data. So what we call now big data will be just data in 5 years from now. So it will be the same trend. So welcome to the thing, we cannot avoid data. But the good thing is that with a lot of data, a lot of computing power, and a lot of technologies, so there is a kind of adoption. Actually, by consuming the data, analyzing data, getting insights, all the businesses are trying to actually make them smarter. So that's the good thing about it.
From my perspective, when the data explosion started happening about 5 years ago, it was a real big problem, right? There was the tools just weren't there, the approaches weren't there, right? Just think about this: the classic approach to data was, you have a fixed data set, and your statistical and other methods were based on fixed, kind of data sets. It's really well known and understood. Well, that didn't work when you're talking about Google and Facebook and Twitter and folks that are at that scale who basically have just constant streams of data that they had to basically reinvent it. And so for several years we were kind of in the dark as to actually how to handle this. And then they basically just kind of rethought the whole approach. Fundamentally they said, we're going to have to work on the stream of data as opposed to the set of data. And that really was a fundamental different approach to not only the technology but even the statistical methods that are at the base of artificial intelligence. And that's why you see tools now like Spark and other things that have come out, and interestingly enough, in open source, right? So these things, cost really de minimis to get bootstrapped with, and it's really, really revolutionized things. So there was definitely a time when it was really uncomfortable because everyone said, hey, you have all this data, you should do something with it. Well, we didn't have the tools, but now at least we have the tools for that. So.
Yeah, I think that's right. I think the term big data, we've become kind of fatigued using this term over and over, and there's been so much hype about exactly what's the impact in the industry, what kind of different value can be created from this concept of big data. And I think the issue with it is that it's just not, the result of big data is not just creating value just because we have all this information. It's really the combination of having the information, having the tools, as Andy was talking about, but also having industry buy-in and having people that are really willing to take a risk and willing to invest and really try to take this technology to the next level. So just for the fact that we have all this data out there is not that interesting, and I think a lot of people are kind of disillusioned by the result of this information. But when we start having buy-in from industry and we start having the tools in order to analyze this information, it starts getting really interesting, and we start kind of entering this era where we can really generate value in industry and see a result that we can be happy with and excited about.
Sure, and I would say that the insurance industry, since time immemorial, has been about analyzing data, so that's not necessarily a new trick. But your company in particular is working on new ways of taking these giant sets of data and making them usable, figuring out a way to teach, like how they can teach us things. Talk to us a little bit about the practical applications. What are you actually seeing on a day-to-day basis that people are using?
Sure, yeah, companies have been using data for as long as data has been available. But in a very quantitative way, people use a very limited set of information to make very impactful decisions. Whether it's insurance or it's making an investment decision, they use a pretty slim set of information in order to drive that decision. But with all this new data that's available, you have information that's qualitative, you have text-based data sources, a whole host of new data that we can be leveraging that we haven't been, but now that we have the capability and the tools in order to do that, there's a really exciting opportunity to take this text-based information, turn it into actionable insight, and then make better decisions, more informed decisions that ultimately make a better result at the end of the day.
Yeah, as you alluded to, insurance has always been a data-driven business. However, the data was, here's this really long application, please fill it out, right? So it's stated data. Well, there are a couple problems with that, right? First of all, there's a lot of friction in that process, right? To do that, collect that information. But the second part was verifying that data, right? Whether it was for just, errors or, ill will, that was a real problem. Then there's the third question, we would insure a business like this restaurant, and today, you'd say to them, okay, how many employees do you have, and what's your revenue? Is that really the best way to assess the risk of whether or not someone's going to slip and fall on that staircase over there? No, I don't think so. I mean, we have to learn new ways, but that's the only information I can practically ask them for that we could practically collect. Now what we're doing is deploying things like sensors and drones and other pieces of data and IoT types of things so that we can actually get much more intimate, type of data and have it come in a stream again. So it's not just, okay, I'm going to assess, I'm going to write you a policy, and then we'll talk to you in a year when it comes up. I'm actually getting data constantly through the stream, but then also it changes the conversation where we can help talk to them about their risk management. It turns into, instead of insurance like, oh, that thing I have to do so for the worst case scenario, it's actually about, no, I can actually help advise you and make you, kind of a better business and help your bottom line. It's a real ROI play.
Okay. Just to add to this too, machine learning is nothing. It's not new. A lot of statistical techniques are there. So those used to be pretty good in structured data. But now what's happened in the last 5 years is a lot of data is unstructured. So with unstructured data, there is actually a lot of uncertainty and ambiguity. So humans actually are better than machines when there is this kind of data are there. With structured data, machines have been proven to be better anyway. So speed of calculation. But what has happened is three things happened: the type of data, nature of data, the technology, as Andy said, and the platform. All this together, and the recent technology advancements, for example, deep learning and so on, has made this complex decision makings where there is uncertain data and also there is fuzzy factor there. That's why actually AI has stepped in to actually help make better decisions.
So, with these kind of leaps that have been made, particularly in how you analyze the data, are you guys worried at all about there being a parsing? It seemed like, before everybody had the same data, everybody had about the same tools. You analyze it, you came out with the answers that you think are right, and you executed on those. Now we have these very advanced techniques, some technologies that are very exciting, but not everybody necessarily has access. Are we seeing, a big difference between those two groups, and are you guys worried that, suddenly maybe one insurance company figures it out, and then they become the only insurance company?
So that's a good question. So I think there are three things: data, technology, and the platform, right? So technology is so data actually is a key. So whoever has the data is the king. So technology and the platform, the barrier entry level has been quite a bit decreased in the last 10 years. If you look at it with the cloud computing, as well as the API-driven services, now actually you can go to Amazon or Google or Microsoft or IBM for a few dollars. You can actually rent 1,000 machines for an hour with the most advanced technology that actually takes like hundreds of years of scientific lab work to create, like analyze the image, right? So the accuracy of image analysis is better than human right now, okay? To the 99.9997. If you give two images to say are they similar or not, that technology has last couple of years, and you can just, with a couple of dollars, which used to take a lot of scientists, PhDs, like 10, 20 PhDs. So I think with a simple API call, you can just upload your picture. With a click of a button, you can get an answer. So technology-wise, platform-wise, that barrier actually has decreased quite a bit. And with also a lot of parallel computing, for example, with GPU, the cost has decreased quite a bit. So you can analyze huge amount of data in very short time. But where I think is the barrier is our data. Whoever has our data, they're the king. That actually is slowly with government and other institutions coming in and making public data available, that barrier probably will slowly decrease. But yeah.
Yeah, I don't
fast.
worry there's only going to be one insurance company in the sense that you still have to take on the risk, right? And there's trillions and trillions of dollars of risk out there, and obviously there's no institution that's at that scale to take on that risk. Because again, no matter how much better data we have and how much better we underwrite, there's still going to be hurricanes and tornadoes and floods and other things to deal with, and so I don't worry as much about that. In fact, I would even be an advocate for leveling the playing field for the data. Everyone should have access to equal amounts in open data, and that would actually, I think, generally be better for the industry as a whole, so that we could actually have a level playing field, and then people could decide what risks they wanted to take on, right? Because again, that's what you do. Even for like a specialty insurance company like ours, we tend to take on the really hard stuff, the really unique stuff, just because that's our profile, that's what we're set up to do, that's what we have expertise to do. We're not suddenly going to go start doing auto insurance for your average consumer, just because that would just be a whole different swath, right? And so each one of those. So I think it's a leveling. We're going to go through a period here, probably the next 5 or so years, where there is going to be choppiness, because there's going to be pockets of expertise, because there's not an unlimited amount of PhDs in data science and things like that. However, you're seeing a trend toward where the power of the tools is getting to where they're also being turned into service. So something I'm pretty excited about is AI as a platform, right? So you have things where people are actually having neural networks that can actually create themselves. So it's not crazy to think in that maybe 5, maybe 10 years, someone can go in and say, this is my problem, this is the data I'm interested in, and the neural network will actually build itself. I mean, that's starting to happen today. I don't think we're quite there, but that's really where it could actually head toward. So.
Yeah, I think one other thing to add about that is like a great equalizer force in the market is all these startups that are popping up and doing different expertise and going really deep, and they're getting the talent that some of these organizations aren't able to access, and that an organization that's looking to tap into this various technologies can partner with these startups and leverage that capability that they may not have been able to build in-house. So when you think about how do I kind of engage with this new technology, how do I get into this new space, it's going and finding the right types of startups and small companies that are really pioneering the field, using their technology, partnering with them, and being a good partner that's not about dragging them along and kind of being a tough client, but it's really about viewing it as a two-way street. You're giving data, you're giving expertise, and they're giving you technology and their expertise on the technical side.
So interesting. Like one thing we wanted to get to here, and thank you to the city of Austin, who I believe helped put this on, is where are governments on all this, and how are they analyzing risk and using the data that they sit on? Because it would seem like if data is one of the big pieces here that's unequal, governments you would think have a lot of data, but I don't think people think governments are caught up or on the bleeding edge. Is that wrong, and what do they need to be doing to get there?
So governments historically, and I think still to this day, are the greatest warehouses of data, right? So everything from the census, even look at advertising, an industry I worked in at one point. The reason that advertising was still targeted like age and gender and things like that is because the only data they had was the census, right? And so that's why it's actually been proven out from an advertising standpoint. It's not actually a great way to target, right? So the same thing here. They have your tax data. They have all this information, permits filed for buildings, things like that. So they're sitting on the greatest resource. But of course, we know our governments are not necessarily the most nimble, resources. I use the metaphor though of how government has adapted to a different environment of the military. So the military, the U.S. military was built, over the 20th century to fight big land wars and nuclear wars and giant armies and things like that. When the wall fell and things changed in the early 90s and it became about terrorism and guerrilla warfare and things like that, the military adapted, right? They basically went to special operations, and that's what you see most of the military action these days are special operations, and they broke all the traditional military rules and redid it. So the question's going to be for government is, you're sitting on an amazing massive data plus what you can get from the public resources and things like that online. Can you actually be nimble enough to actually move as quick? Because the problem now is the scale and the speed at which these bad things happen and bad guys do these things is incredibly fast and incredibly large scale, which is unprecedented. So can the government be nimble enough to do that? And then, oh, by the way, what are the political winds that are blowing at the time to depend on which ones they want to take on and which ones they don't, they turn their back on, right? So that's the other factor as well there.
So just to add on to that, slowly government, open data, for example, in NYC, right, with the Bloomberg effort, like Columbia, NYU, Cornell, they're hosting quite a bit of data. Slowly they're making public. So similarly, even from the private sectors, right? Netflix has Netflix competition. Kaggle is open source kind of like a lot of machine learning data sets are there. Even Yelp, they made a lot of data available. So similarly, slowly, as you will see that, from both sides, there is going to be reasonable amount of data slowly available. But everybody's scrambling. Hey, there's a big data. A lot of things. What am I supposed to do with this? What's my role in this? So there's a lot of confusion, a lot of aspirations. Any CIO go to any company, they have to do something with big data, right? So this is settling down. So everybody's trying to figure out what do I do with it? So what's my role in it? So as we make progress, time is right. Meaning that a lot of data, a lot of sensor technologies, a lot of platform technologies, a lot of computing technologies. Everything is is a perfect storm. Everything's coming together. What Google, Facebook of the world used to secretly do on their own thing, now it is going to be the fingertip of everybody. Like even just a bus schedule. What should be the bus schedule of today? What's the snow plowing schedule for tomorrow? Everybody has a fixed schedule, but now actually it can be a lot of smart city efforts actually, which are already there in some sense, are starting to realize, wake up, and make it more and more efficient. So it's going to take some time, but it's going to get there.
You definitely just made me feel a lot better about like Google and Facebook, because I worry sometimes that they would eventually own the world. There's one thing that I wanted to ask. It's like a slightly broader question here, though. I think particularly around the election, we saw a lot of like public data, public use of kind of polling and projections and things like that. Slightly different topic, but I think people look at data and data analysis as this kind of magic box that spits out the answers and it's always right. But what are the biggest misconceptions to you about the role of data and data analysis and kind of the growth we've seen?
Okay, if you're election, right? So that's a very tricky subject, right? So
you don't have to talk politics.
No politics, yes. So, but here is the thing, right? So garbage in, garbage out, right? So when the polls they do it, right? This sample, they basically sample, and that kind of data is very tricky. That is very tricky, very unpredictable, human factors. So yeah, so I would pass that question. I just paused there and said, the data collection, the result could be as good as the data quality is. So especially in that kind of areas, the data quality is very questionable to the last moment. So probably that's kind of the human error. You can err a lot of factors. So
I would just continue with that and say, we still have this wonderful thing called human bias, right? So you said it's analysis, right? We're nowhere near the singularity. The machines do not have sentence and things like that. And so there still has to be a human involved in interpreting or analyzing that, and we're still just loaded with that human bias. We haven't figured that one out yet. So.
Yeah, I think the other thing to add to that is that a lot of the systems we build and the statistical models are just inherently probabilistic, and that just because we've modeled all the information, we kind of look at all the factors in the right way, it can go either way. It could, even if you're 90% sure, there's still 10% of the time that it goes in the opposite direction. And I think it's actually something dangerous to think about when we're on the phone and we talk to Siri and he gets it wrong once in a while. We don't stop using Siri. We continue to use it and we do it over and over, and the net result is something positive to our life. And I think there's a danger to look at one occurrence or one event in the market and say, maybe everything's totally wrong, maybe it's just systemically incorrect. But in fact, that if you play that out over and over and over, the answer starts to become a little bit more stable. And in these events that are very kind of a single event, it's really easy to look at that single event when it was potentially incorrectly estimated that it's wrong, but in fact it was just one event and it wasn't averaged over many occurrences of a similar event.
And Andy, I wanted to get back to something you just touched on too, which is kind of the human element in this whole situation. So insurance companies are still companies with people in them. They're not entirely machines just yet. Is that a problem? Is that a problem you think can be solved? Like, how do we make sure human biases aren't ruining good data, good analysis?
Right. Well, and is it going to take all our jobs, right?
That's on the sheet. I didn't want to say.
So, here's the thing that I say in the current state of the art, and I think it's going to be that way for a while. It is the combination of algorithms helping people be better assessors of risk, or people being better decision makers. That is where it is, right? Let's have algorithms do what algorithms are good at, which is complex math, working with really large data sets, things like that, and have people do the things they're good at, sales and negotiations, and other types of things like that. And as I said, until we reach the singularity, if we ever reach the singularity, we are not going to, we're not going to have machines that are going to be at that level of advice. So, for example, we do something, we just released a product internally that basically helps our underwriters assess risk. So when I joined 6 months ago, we just looked at the underwriting process, and they were spending a large portion of their time just what I would call clerical stuff, which is just collecting the data from 10 different data sources to understand this complex risk. Because remember, we're not doing stuff where it's like 3 or 4 pieces of data and it's okay. I'm doing really, really hard stuff, and so they have to look at everything from flood maps to crime data to all these other types of factors, and they're spending all their time just collecting the data. So we basically just built a tool that could basically go collect all that data and put it into one place to digest it and say, this is the most important information. Now we're going to keep taking that further and further, but it's actually focusing them on what they're really good at, which is what they're trained in, which is risk assessment. So I think the combination of the two is what's powerful. And then the interesting thing we found out from that process, we thought the main outcome was going to be that we sped up what they were doing, and that was a factor. But actually what we found was error reduction. So the machines catch the errors, right? So errors would happen. We went back and looked at one of our books of business, and we found that there was an acknowledgeable percentage of the book that was just misclassified. And misclassified in the insurance business as really bad things, happen there. And so we were able to basically catch the human errors with the algorithms that basically said, from all the factors that I'm looking at, you said this was a residential plumber. Well, when I look at everything from their social media posts to all these other things, I actually say that they're a commercial plumber, and that's a very different profile. So that's how we can not only make them faster, but we can actually make them better.
So let me ask a very broad one here, but what's the weird stuff out there that we're just starting to see as far as data analysis go? It could be within insurance or not with insurance. Obviously, you guys at IBM and Watson are doing some pretty incredible stuff around like analyzing medical images, things like that.
Yeah, actually, there are quite a few areas, right? Transportation, we are seeing the driverless car coming into the different streets, medical imaging. So that's why actually where we have seen a lot of benefits. So doctors, of course, no one can take doctors' intelligence, experience. I mean, the machines actually are not to replace them, actually to actually aid them, to make something uniform. So there are millions and millions of images taken across different hospitals. So by analyzing that, machine can get into more uniform analysis, so that can actually provide as a cue, hey, how about this? Maybe you understand this. So when actually you're looking at a vast amount of data, machines actually are good at detecting the patterns. But the final decision, that actually gives a better way or clue to doctors to actually make better decisions. That's how actually we are using Watson, for example, as an example, to analyze huge amount of data, find patterns, provide more uniformity in the process rather than replacing human decision making. That's what I would say.
For whatever reason, it's top of mind here, and there are actually some very interesting discussions at South by Southwest about some of the scarier stuff that's going on, because criminals get their hands on these things, these tools as well. The democratization of the tool and the techniques means that bad guys get it as well. And so the interesting thing for me is how that, back and forth, and are we going to be able to keep up with that? So some of the interesting things we're talking about, having AI fight AI here, right, which gets into all the kind of weird sci-fi kind of stuff, but realistically, things like where, for example, cyber penetration of your network, right? So everyone knows that today there's no way you can do true border control of your tech network, right? There's you just can't keep everyone out. It's nearly impossible. So there are people that are deploying artificial intelligence inside networks that are looking for the anomalies there. And in fact, there's a company that's doing some really interesting stuff that's actually building an artificial intelligence security system that works like your immune system. So it actually knows what your internal network looks like when it's good, and then when it sees something that looks out of pattern or unusual, it basically goes and it isolates that, right? And it basically says until they can get in and assess it. But then again, here's where the humans come in, because it can basically tell you where to go. It's always the thing about data, right? Is it tells you where to, what questions to ask or where to look or what to do, but you still have to get in there and do the qualitative analysis to understand what's that, and that's where the human part is still quite good. So.
Yeah, I think there's a lot of really cool things, autonomous vehicles, a lot of the things that you guys have already talked about. But I think the most exciting thing that's going to happen over the next few years is the operationalization of a lot of the existing technologies. A lot of this is kind of academic. We think about it, we try it in small sample sets, but seeing it actually go into industry and start making impacts on companies and people's lives. And over the next couple of years, this is going to be more and more of a reality. And while things that we were excited about in the past are going to start coming into our lives and making impact, which is what I'm most excited about, is seeing it actually come into the world.
Yeah, and that's gonna be, this could be my last question, which is like, yeah, I mean, it's fun to talk about these things very high level. I love that stuff, but what on my phone is a great example. Like, where are we seeing this kind of actually impact people's day-to-day lives?
Yeah, I mean, I think in risk assessment in particular, the using qualitative text-based data is actually, I think, next on the time horizon. It's what we're working on now. It's what we're starting to see being deployed, and I think it's something that industry is starting to adapt more and more and get excited about. And we're getting buy-in from different players, and as certain kind of players start to kind of go with the technology, other players are starting to get involved as well, and you can't be left behind. So yeah, it's getting exciting. It's definitely getting exciting.
Yeah, I think in the small ways, it's a lot of the little ways that are interesting. So I was just traveling in South America, and on my phone, not only did it pop up and say, oh, do you want to translate a message? And they could do cool things with computer vision where you could translate the sign in real time. Okay, that's cool. But the most interesting part to me was the translation examples it gave me. It knew where I was at, right? So it knew I was in a restaurant. It knew I was in the airport. So I was in the airport. It said, in English, how do I check in to go to Spanish or something like that. That was interesting. On my ride here to the airport, I wasn't using navigation or anything, but Google said, oh, there's an accident coming up. But the interesting thing was, the accident wasn't on my route. It wasn't on the road that I was on. It was on the future route. It was predicting where I was going, right? And so that was very, very interesting to me. I hadn't put anything in. It had no information about where I was going, what I was doing, but it basically knew, because people traveling like this in that pattern typically go here, and so I'm going to warn you about this. And oh, by the way, it was right. So that was what's really interesting. So you're seeing it, and Google in particular is really operationalizing this quite well now, given the scale of the data and their deep, deep investment, in machine learning. And so you're seeing that really starting to come to life in those little ways that just make your life that much easier. So.
Yeah, so what's happening is now machines are slowly trying to behave like human beings, right? The interface checklist, right? Understanding speech, understanding images, and visuals, and so on. So the blur, what is interesting to me is that the blur between the digital and the physical world is slowly kind of disappearing. Less seamlessly in each digital world and physical world, they're trying to communicate in a very seamless way. So I think that's exciting, and also a lot of services actually kind of there now, actually all coming together. So simple things, like example you give, the Google Now, for example, simple things. Hey, you have a flight in 15 minutes. By the way, you are here. There's an accident on the road. You should be taking a taxi, right? Uber taxi for you. So, and by the way, the Uber is going to be somebody is going to come without any driver. So, so this kind of the whole suite of seamless, like the Google Assistant, for example, right? Or anybody is looking at a virtual assistant. That technology actually is kind of personalizing. It's not just generic Gmail, generic Facebook. It's kind of very personalized for you in your phone, just in your phone, and everything actually personalized for you. Every service that you're looking at, restaurants, when you go to Yelp, it's not going to be hundreds of restaurants. No, it's top 5 restaurants based on the past histories, everything getting personalized for you and pertinent to your thing. I think that kind of, the machine is thinking for you, taking away a lot of clutter, a lot of like dirty work, a lot of work that you spend a lot of time, which actually you shouldn't be spending. I think that is very interesting for me. I mean, even this simple things, the frictionless, simple frictionless stuff is pretty interesting.
Excellent. Very cool. Very cool. Yeah, let's try to get a couple questions if we can. I think we can just do hands and speak loudly if you can. Man.
What about privacy concerns with data collection and data analysis? Is it just we're exchanging data for services? Is that the world we've entered into?
Let me tell you, when you actually check in on some, accept a Facebook or some of those things, you really don't know how much information, where you're going. That's one thing. But in research, actually, a lot of technology, privacy preserving way, meaning that you don't reveal all the identity. So there is a lot of research how basically is not there yet, but is getting there. Differential privacy, meaning that if you want to get a taxi, the amount of privacy that you need to expose, versus if you want to get a bank loan, or if you want to actually buy a house. So it's automatically going to actually try to curtail how much information should be slipping out. But your question is definitely right, meaning that you right now you click few things, you don't know how much information actually you are putting in the web.
Yeah. Yeah, I'll give you a dual answer. I'll give you my official answer, and then I'll give you my personal answer on that one, which is, the official answer is that we have to respect privacy, and we have to come up with new ways to exchange that privacy, understand what that exchange is, and your ability to control it. My personal answer is, all the data's out there, and the cat's out of the bag on this one, I think. I really don't think you can stuff that one back in unless you want to go into the woods, have no technology, and just kind of cut off. Personally, I really kind of disengaged with Facebook about 3 or 4 years ago, just because I said, I'm not, huge on, worrying about, what people are doing with my data, but it was getting to the point where I felt it was wrong. And if you read the stories about, supposedly what may have happened in the election with manipulation by a company in the election of promoting fake news and basically targeting your behaviors and emotions based on what you liked on Facebook, that's very real. I don't know if that happened, but that technique is very feasible and achievable. So you're giving up, worrying less about your bank loan and who might use that on it. You're giving up tons and tons of really, really valuable data every time you're on Facebook, just looking at things and liking it. So, another question?
Yeah, I do. So 2 questions. One is regarding on the insurance side for actuarials. How do you convince them, because they don't tend to give a crap about in embracing the AI aspect, because of the fact that they build it into the tables.
Yep.
So they got it covered, and they don't care to listen to the solutions, the potential for those.
So I'll repeat the question. So it's basically, how do you get actuarial techniques and actuaries to basically care about or be interested or be able to use these new techniques, basically, right? Because they have very traditional ways that they're trained and they use things. So yeah, one is, I think the biggest challenge is a cultural thing. It's been done that way for hundreds of years, right? When you go back and look at history of Lloyd's and things like that. So what we've done is we actually have deployed in pairs actuaries and data scientists working together. We are teaching them how to kind of come together. But what we're doing is we're seeing, especially in the younger generation of actuaries, they're familiar with some of the data science tools, right? They're starting to learn on that. And we're teaching them that, hey, it's not just about looking backward and trying to build a model, but you can actually now look forward and have data kind of happen in real time. So we're translating that for them to have that work together. And for us, the best effect we've had is we've built this new compute platform for us to use internally. And we just have the actuaries coming over and starting to use it, and they realize the power of having a massive amount of data for back testing that they've never had before. And so it's getting them onto it and understanding that and doing that. And the big thing is understanding that, hey, you don't have to just use the same old risk variables you've used for the last 50 years. And looking at this, like I said, with this restaurant, there's a bunch of new stuff where I could fly a drone over it and look at the roof exposure, right? And do that kind of stuff. So we've seen them getting pretty excited by it, but we're still in that era of trying to figure it out. So. So you want me to insult my actuarial team here? That's a question. Please insult your actuarial team. So the question was, what changes are we finding? What things have we uncovered? Have they found errors or problems in what they've done? I'd say this. I think it's still a little too early, because a lot of the techniques that we're employing, we've really just been employing the last year or so we don't have enough data to really say we found a massive error in what you're doing before. However, one example I'll go back to was the one I gave earlier. When we looked at just one of our books of business, we found that a percentage of it was just misclassified. And it was just because of the human classification, right? So I'll go back to the example I gave. So, someone makes an application and they're a residential plumbing company, right? And they say, yeah, because 60% of my business is as a residential plumber. But I also happen to do commercial plumbing. And oh, by the way, when the town calls, I do the municipal stuff as well. Well, guess what? When you flood the house, there's one level of exposure. When you flood the town, there's a whole other level of exposure. And you can imagine the premiums are quite different. Now, did they classify themselves or get classified as residential, just accident because someone just quickly looked at, their 60% of their business was doing that? Or did they know, guess what, the premiums are going to be an awful lot lower if I'm a residential plumber, right? So what we're doing is we're now basically going out and looking at basically how they represent themselves in social media, advertising, and other things like that, and have algorithms that basically can actually do the classification. So in fact, we're moving to a model where the algorithms do the classification and the humans verify it. So, and that's something that's been working better so far in early testing for us. So.
Yeah, so the question was, how does AI impact gender and racial bias, correct?
Well, I would say one thing, back to again, human biases are now being built into the algorithm, so we have to be very careful about that. There have been a few very famous, well-documented things where Google image search had some really kind of pretty, what we consider pretty appalling, types of results, and things. So the problem is, how do the algorithms? So what happens, when you train these systems up, humans do the first training, right? And now we're trying to get better to where the algorithms can kind of train themselves, or they don't have to have unsupervised learning. That's still in the early days. So we think that we can, we hopefully can, merit out some of those. I mean, the thing that we've always said amongst engineers and data people is that it's about the data. It's not about who does it or who produces it. So one would hope that we can ferret out these types of things. But again, we still have the problem that humans are training the systems, and even people that don't have an overt bias, there still are things going into that are doing it. And the problem is, as you see people who game Google and other things like that with fake news, all these other types of things, people are also doing countermeasures to try to do that. One of the attacks that I heard the other day here at South by Southwest was people who are attacking AI systems with massive amounts of data to basically build a bias into the system, right? So it's like, I have a bias and I'm trying to do it. So how can we actually thwart that and fight that? And we haven't figured out the countermeasures to that yet. And that's a really, really interesting, kind of research area. I don't think anyone's really, gotten that there yet. So, but so again, what we're doing now with data, the state of the art, is we're just replicating the stuff we're doing as humans into the data. The question is, can they become better and more intelligent to basically kind of, push them out? So.
We got time for one more, if we've got one more. No, that's it. Yeah, let me
Do one more there?
Quick question.
Okay.
So on the law enforcement side in particular, people are exceptionally sensitive to the fact that there could be potential influence from a gender, a race, a religious aspect. How do you convince, with a predictive analytics point of view, for where crime analysis will go without the implication of exploring the human aspect of it?
Right. So I'll repeat the question. So basically, if I got it right, from a law enforcement perspective, we've certainly had things, I guess, racial profiling, things like that have happened, right? So how do you ensure that as we bring these techniques into law enforcement to better assess, the threats, that they face, to not again have the same biases, built into it? I would say similar to the previous question is, we have a challenge now in that humans are training up these systems, and so that's where our biases, whether they're overt or subliminal, are getting built into those models, and so we have to wait, get to the next generation where these systems are actually training themselves a bit to go beyond that. I think it's a very hard question, to be honest with you. I don't know that there's any easy answers. I certainly haven't seen it, out there in the research. I think it's a fascinating area to dive into to see if we, theoretically remove the human element to it, can the data alone speak to these things and not reflect, those biases? I don't know that anyone's proven that yet. At least I'm not aware of it.
Yeah. So,
I mean,
when we train our models, we're using a lot of expert input, as Andy was saying, and I think the issue is just that if the bias is in the expert's opinion, in the expert's kind of interpretation of the world, it's just going to be reflected in the output at the end of the day. And you're right, as far as when we have to go past our current methods, and I think those are several years out, and before we can really go beyond the expert informing the system, and the system not reflecting anything that the expert's putting in.
So if may I add one more thing. So there's new technique people are trying to go towards. The classical machine learning used to be more statistical and find patterns and features, like you look at the features and then that's like human beings actually try to derive the features. So the new science, deep learning, that's actually pretty recent, like it's been old but been practical last few years. That doesn't actually depend on any extraction of feature. So it's basically throw all the data, huge amount of it, but it needs huge amount of data, and throw huge amount of computations. It automatically tries to detect the feature. You don't actually restrict any 5, 10 or 20 features. So even if it's a cat, so okay, tail, this thing, this. So a lot of science actually goes into extracting features. But now that actually has changed. So I think that could actually, hiding that layer from the training set probably would work towards removing some of this bias if you have huge amount of data.
Yeah, I would actually just add one more thing, because it prompted me to something Samba said was, just like I was talking about are we assessing risk on this venue the proper way by asking for their employee count and their revenue? Well, that's the easiest thing to ask them for, so I guess that's what I'm going to ask them for. Same thing when you racially profile someone, right? Would I use my vision, right? First to look at and form an opinion about that person based on what I visually see. Well, what if we actually said, let's roll back to first principles. What are the true indicators of someone being, going to a life of crime or doing some type of act? We have studies now that show, okay, maybe it's how they were raised or their economic situation or those things. You as a law enforcement officer could never assess that in real time and understand that, but if we actually had data in real time that could indicate the risk profile based on actually the true indicators as opposed to a false indicator like race or something like that, so you could do that, right? So again, that's kind of a pie in the sky idea, but that theoretically could be done where we roll back to first principles because we actually have the data, something that's not available to someone today because they're just using their visual cortex to do that.
Excellent. Well, the data is telling us it's time for drinks. So, man, I didn't think anyone was going to laugh at that. Thank you guys so much, Andrew, DataDriven, Argo Digital, Dr. Sahu at IBM, and we'll see you guys inside.
Thank you.